Welcome to my channel University of Universe. Hi. Imagine a force so impactful that it has the potential to reshape global weather patterns and even affect the course of ancient civilizations. Earth's short-term weather patterns and long-term climate are shaped by a complex mix of factors, from its position within the solar system and planetary rotation to atmospheric dynamics and seasonal changes. Complicating these factors further, every few years, Earth experiences El Niño and La Niña events, two opposite ends of the El Niño Southern Oscillation (ENSO) cycle. Evidence suggests that ENSO has existed for tens of thousands of years, potentially even contributing to the destabilization of some ancient civilizations. As of June 2024, one of the strongest recorded El Niño events has come to an end, leaving behind months of record-high ocean surface temperatures, severe stress on coral reefs, drought in the Amazon, and intense rainfall that affected North America with significant consequences. With La Niña predicted to begin in late 2024 or early 2025, how might these events impact the globe, and local regions specifically? In this discussion, we'll dive into the shifting dynamics of our planet, exploring the ENSO cycle and the potential consequences of the incoming La Niña. In a previous discussion on El Niño, we examined one extreme of this global cycle, which typically shifts between El Niño and La Niña every 2 to 7 years. These episodes generally last 9 to 12 months but can sometimes persist for several years. This time, we'll explore how the cycle operates, the conditions in neutral periods, and what may occur as we approach La Niña's influence in the coming months. During Earth's neutral periods, which are called ENSO neutral, average conditions predominate. However, fluctuations in wind and ocean temperatures occasionally signal an approaching El Niño or La Niña event, deviating from Earth's regular conditions. These fluctuations disrupt atmospheric patterns worldwide, often resulting in extreme weather events and ecological disturbances. Imagine viewing Earth from the International Space Station. The sunlight reaches our planet unevenly, with more intense light and heat hitting the equator due to its direct angle, while the poles receive sunlight at a lower angle. Similar to a hot air balloon rising or steam rising from boiling water, the air at the equator warms up, becomes moist and low in pressure, and ascends into the atmosphere. As this warm air rises, it cools and condenses into clouds, hence the concentration of tropical rainforests near the equator. As warm air continues to rise, it pushes cooler air away from the equator toward the poles, where it eventually descends and flows back toward the equator, completing the Hadley Cell rotation. How does this sun-driven global air circulation relate to El Niño and La Niña events? The Hadley Cell surface winds are directed toward the equator due to the Earth's rotation, a phenomenon called the Coriolis Effect. This effect creates the trade winds on both sides of the equator, and it's changes to these winds that can indicate the arrival of El Niño or La Niña. Historically, sailors depended on the trade winds for navigation, hence their name. ENSO's influence stretches back tens of thousands of years, preserved in paleoclimate indicators like coral fossils. Written records of ENSO date back to the 1500s, with evidence suggesting El Niño may have impacted Spain's conquest of the Incan Empire and possibly contributed to food shortages that fueled the French Revolution. However, the detailed mechanisms of ENSO weren't understood until the 20th century. A breakthrough came in the 1920s, when British scientist Sir Gilbert Thomas Walker investigated India's monsoons and ended up identifying the Southern Oscillation, a repeating shift in air pressure across the equatorial Pacific. This oscillation revealed another large-scale air circulation pattern, later named the Walker Circulation. While Hadley cells move air north and south, the Walker Circulation transports air east and west across the Pacific. Instead of solar energy, the Walker Circulation is guided by easterly trade winds and ocean temperatures. It took 60 more years before scientists could link Pacific air pressure shifts to the fluctuating warm and cool sea surface temperatures that characterize El Niño and La Niña. Together, these air pressure and temperature shifts define the ENSO cycle. El Niño refers to changes in sea surface temperatures, while the Southern Oscillation describes the simultaneous air pressure shifts. Unlike the consistent Hadley cells, the Walker circulation can experience significant shifts during El Niño or La Niña, upsetting global weather and ecosystems. But what actually happens to the Earth in each of these phases? During ENSO neutral periods, average conditions prevail in both sea surface temperatures and trade winds. Trade winds carry warm surface waters from South America toward Asia, while cooler waters rise to the surface near South America in a process called upwelling. This upwelling supplies essential nutrients to marine ecosystems, supporting phytoplankton and, subsequently, fish and other marine life. In neutral periods, global weather patterns are relatively predictable. This includes typical hurricane formation in the Atlantic and average monsoon rainfall across Southeast Asia. The Walker circulation drives moist air columns over regions like Southern Asia and South America, creating a favorable environment for rainforests. The extent of this airflow makes it easy to see how changes in the system could reverberate worldwide. When trade winds weaken and sea surface temperatures rise in the Pacific, an El Niño event may be on the horizon, similar to what occurred in 2023 and 2024. During El Niño, the typical columns of warm, moist air shift, causing disruptions such as drought in Asia and the Amazon and excessive rainfall in North America. El Niño events can bring about extreme phenomena like atmospheric rivers, which are streams of moisture in the air. When these hit land, they produce intense precipitation, sometimes resulting in flooding and landslides. While the impacts of El Niño are global, local conditions can vary significantly. Typically, El Niño brings a reversal of typical weather conditions, with rain-prone regions like East Asia experiencing drought and typically dry areas like Western North America seeing heavy rains. The 2023 to 2024 El Niño even caused global shipping delays as reduced rainfall led to low water levels in the Panama Canal, hindering cargo ships from passing through. El Niño is considered the warm phase of the ENSO due to elevated Pacific temperatures. These warmer waters disrupt ecosystems, affecting coral reefs, which depend on specific temperatures for survival. Higher temperatures cause coral bleaching, a loss of algae that leaves coral vulnerable. While reefs can recover if conditions improve, El Niño events like the last one caused widespread bleaching, impacting nearly all of the Atlantic's tropical reefs. In warmer Pacific waters, reduced upwelling limits nutrient availability, forcing fish to migrate or die and potentially affecting human communities that depend on these fish. Now, let's consider La Niña, which has opposite impacts to El Niño and is marked by strengthened trade winds and cooler-than-average Pacific sea surface temperatures. La Niña is best understood as an intensified neutral phase, with the usual columns of rising warm air becoming even more pronounced over southern Asia and eastern North America while reversing over Africa. Similar to El Niño, the effects of La Niña differ depending on location. As of August 2024, the U.S. National Oceanic and Atmospheric Administration, NOAA, has estimated a 66% chance of La Niña developing between September and November 2024, with a 74% chance it will continue into the Northern Hemisphere's winter of 2025 to 2026. Forecasts currently indicate a moderate La Niña, although predictions of strength vary month to month. Notably, a strong El Niño does not guarantee a strong La Niña. Sometimes strong El Niños lead to weak La Niñas and vice versa. In the Northern Hemisphere, La Niña typically brings cooler, wetter winters to northern North America, while the southern regions might experience a warmer, drier winter. Notably, La Niña increases the likelihood of more active and powerful hurricanes in the Atlantic. In regions like East Asia and Australia, La Niña tends to bring heavy rainfall, while Africa may experience mixed conditions, with wetter conditions in some areas and drought in eastern regions. In Europe, La Niña may bring cooler-than-average temperatures to central and western areas, with drier conditions across the mainland and increased precipitation to the north and south. One critical aspect of predicting La Niña is considering the role of climate change. While ENSO events have naturally occurred for millennia, the influence of human-driven global warming is less clear. Short-term temperature fluctuations from ENSO events are overlaid on a general trend of rising global temperatures. As the Earth warms, extreme weather events are becoming more common, and recent La Niña events have been more frequent and intense, resulting in longer periods of drought, storms, and other severe weather events. Although ENSO's long-term behavior under climate change remains uncertain, rising global temperatures are likely to intensify its effects. While these events remain unpredictable, each new ENSO event offers scientists valuable insights that can improve future forecasts, preparing us to adapt to the environmental challenges ahead. Life on Earth has continually adapted to changing conditions, and humanity now stands at a critical juncture. As we enter a new La Niña phase, we have an opportunity to observe, learn, and apply lessons to prepare for the future in sustainable and resilient ways.